Lesson 1.2 review by Sunny, Althea, Divya, and Natalie.
Energy comes in many forms. Wind and solar power are some of them.
Energy is the ability to do work. There are many different forms of energy, which are non-renewable, renewable, and inexhaustible. The primary source of all energy is the sun.
Non-renewable energy sources cannot be replaced once they're used. Another name for them is fossil fuels, and examples include coal, oil, natural gas. Alternative energy is any fuel that has not been identified as a fossil fuel. Uranium is a type of nuclear energy, and it's also non-renewable.
Renewable energy sources can be replaced as they are being used. Food, animals, and biomass, which is energy from organic matter, are also types of renewable energy. Engineers are coming up with ways to efficiently use renewable energy to our advantage.
Inexhaustible energy sources will never run out.
Geothermal energy is the heat from the earth. It can come from hot water or magma.
Hydroelectric energy uses flowing water to create electricity. The most common form of hydropower is a dam.
Wind power uses wind to generate electricity. Wind turbines are mounted on a tower to capture the most energy.
Solar power converts sunlight into electricity by using N-type and P-type semiconductor material.
Here are some review questions. Question 1 says, what is the difference between inexhaustible and renewable energy sources? Question 2 is, what are some types of non-renewable resources? Question 3 is, what is the primary source for all energy? And question 4 is, why is it more beneficial to use renewable or inexhaustible energy sources instead of non-renewable energy sources?
The answer to question 1 is, renewable sources need to be replaced, but inexhaustible sources will never run out. Answer to question number 2 is, fossil fuels such as coal, oil, and natural gas. Question 3's answer is the sun, and question 4's answer is they're more environmentally friendly and will not run out as quickly.
Now moving on to electricity. Electricity is created through the movement of electrons. Light, heat, sound, and motion are created through this force.
Elements are the simplest form of matter. Atoms are the smallest piece of an element that contains all the characteristics of that element. And this is a picture of the periodic table.
Here are parts of an atom. Protons are positively charged atomic particles.
Neutrons are uncharged atomic particles.
The nucleus is the center portion of an atom, including the protons and the neutrons.
The atomic number is equal to the number of protons in the nucleus of an atom.
Here are the parts of an atom. Electrons are negatively charged particles.
They move around the nucleus in electron orbitals.
Valence electrons are the outermost ring of electrons in an atom. This picture here shows what all these three things do.
Electricity is created through a process called electron flow, which is when electrons run into each other and transfer heat. This picture shows the flow of electricity and how it creates heat.
On this slide, we highlight the differences between conductors and insulators. In conductors, electrons flow easily between atoms, while in insulators, electrons flow is difficult between atoms.
In conductors, the outer orbit is made out of 1 to 3 valence electrons, but in insulators, the outer orbit is made up of 5 to 8 valence electrons.
Examples of conductors include gold, aluminum, and copper, while examples of insulators include glass, mica, and quartz. Here are some review questions for electricity. Number 1, what are the simplest forms of matter? Number 2, what does the nucleus of an atom contain? Number 3, how is electricity created? And number 4, what are some examples of conductors and insulators?
Here are the answers to the questions on the previous slide. Number 1, elements. Number 2, protons and neutrons. Number 3, through electron flow. And number 4, conductors, which include metals such as gold, aluminum, copper, and insulators such as glass, plastic, rocks.
Now we are going to talk about circuits. Alright, so what is a circuit? Well, a circuit is basically just a system of conductors and components that are put together so that the electricity or the current has a complete path to travel through and go back to where it started. And the properties of an electrical circuit include the voltage, the current, and the resistance, and we'll talk about the relationship between those later on. And you can actually measure these components of a circuit by using what's called a multimeter, which consists of a voltmeter, a resistance meter, and whatever else you need. Alright, so in the circuit, there is current. Current is the flow of an electrical charge, and that's going through the circuit, and it's measured in amperes, or amps for short. Now, there's different kinds of current flow, and the most generally used current flow is called conventional current, and basically conventional current says that the current flows out of the positive end of the battery and goes back to the negative side of the battery. Well, makes sense, right? Well, actually, this isn't true. The current actually goes in the other direction. So the current flows out of the negative side of the battery and then goes back to the positive side of the battery. That's the direction that the electrons move. So it's called electron flow. And electron flow is usually used in science, whereas conventional current is used in engineering. So for this course, we're going to be assuming conventional current. Alright, so another component of a circuit is the voltage, and voltage is basically the force that causes the current to flow through the circuit, and that would be measured in volts. So generally in a circuit, what's providing the voltage for us is the battery, and the voltage drop across the battery is what causes the current to go through the circuit. And when people say that, and when you see those signs that say like high voltage, it actually means that if you actually touch it, it won't actually hurt you. But if you put one hand on either side to connect the circuit, it's the current that actually will shock you. So that's the difference between voltage and current. Now, the final component of the circuit is a resistance, and the resistance is like the opposite of voltage. It's what prevents the current from flowing, and the unit for resistance is ohms, which is symbolized by the Greek letter omega. And usually in a circuit, what's providing the resistance is a resistor. So the resistors, they're color-coded for different amounts of resistance. And depending on what you put, how many resistors or what kind of resistors you put in a circuit, the resistance can vary. So remember I said earlier that there's a relationship between the voltage, the current, and the resistance. And this is what's most commonly known as Ohm's law. And Ohm's law states that the current is directly proportional to the voltage, but indirectly proportional to the resistance. So in terms of the formula, we write this as V equals I times R, where V is the voltage, I is the current, and R is the resistance. Alright, so now that we have that, we can talk about the different types of circuits. Well, one way you can hook up a circuit is what's called a series circuit, where the electricity only has one path for current to flow. And if you break that path, then the whole circuit breaks. And so if you remove one part, then all the other components quit working. And to calculate the resistance in a series circuit, you simply add all the individual resistances of the components, and you will get your total resistance. Now, the other kind of circuit is a parallel circuit, where the current would have multiple paths to flow. So even if you took out one component, as long as it's not battery, as long as everything else is still hooked up to the battery, the rest of the components can still work. And there's actually a way to calculate the resistance in a parallel circuit too. Basically, you just take the reciprocals of all the individual resistances, then add them together and take the reciprocal of that, and that would be your formula for the total resistance. So we talked about how to calculate the resistance in series and parallel circuits. Now, how do we calculate the voltage and the current? Well, this guy named Kirchhoff came up with these two formulas. So basically, in his voltage law, it states that when you have a series circuit, the total voltage will equal to the sum of all the individual voltage drops. And that means that the current in a series circuit is going to remain the same throughout all the components. And the opposite is true of parallel circuits. Kirchhoff's current law states that the total current in a parallel circuit is going to be equal to the sum of all the individual currents, unlike the series circuits, the voltage actually remains the same. So, and of course, you can also have combination circuits, which can have components of both series and parallel circuits, where like the branches go off in different directions. So, in that case, you would have to calculate like the different branches individually before calculating like the total resistance or current or whatever else you want to find. Alright, so here are some practice questions for the circuit section. They mostly deal with calculating current, resistance, and voltage, and Ohm's law. And you can see the next slide for the answers and explanations that work through the answers, and yeah. Woo!
In this section, we will be talking about work, power, and energy. Yay! Okay, so the first thing we're going to talk about is power. And electrical power is defined as the rate of energy consumption in an electrical circuit, and this is measured in watts, or W. And this is proportional to the amount of current and voltage within a system, and this is this is calculated by the formula P equals IV, or power equals current times voltage. Okay, so there are different types of power. There are three types, and the first type is electrical power, which is basically electrical energy to do work. It's very basic. And then the next one is mechanical power, which uses mechanical energy, again, very basic. And then fluid power uses energy transferred by liquids, hydraulic power, and gases, which is pneumatic power. Okay, so now we're going to talk about work, and work is the energy transferred when force is applied to an object moving through a distance. And this is measured in joules, or J. And the force is usually parallel to the distance that the object moves, and this is shown by the formula work equals force times distance. Efficiency is the percentage of the input energy that is transformed to the output energy, and this is shown by output divided by input times 100, because you want your efficiency to be in a percentage. And the output is calculated using the power formula that we discussed earlier, and the input is calculated using the work formula
that we also discussed earlier.
Remember that energy is the ability to do work. So now I'm going to talk about different types of energy. The first one is potential energy, which is the energy that an object has due to its position and the result of gravity pulling downwards. And this is the energy that an object has when it's standing still. The second type of energy is kinetic energy, which is the energy that an object has when it's moving. And the law of conservation of energy states that energy cannot be created or destroyed, but it can change from one form to another. Okay, so this next slide, all these forms of energy are basically self-explanatory. They're thermal, chemical, electrical, electromagnetic, sound, mechanical, and nuclear. And they all are exactly what they sound like. And one form of energy that's not on here is electrochemical, which is the energy that is in batteries. Here are some review questions that have to deal with Darth Vader, force, work, and power, and the different types of power. Have fun.